the HCF of 42a square b square and 48ab cube. So now to do this, first we have to write the 42 in its prime factors form, and similarly with 48. And after we first, let's do that. So 42, I'll show you if you uh, don't get it. Okay, that's 21 and 3 sevens are 21. So the prime factor form of 42 a square b square will be 2 times 3 times 7, that's 42, and we're gonna write a wait, it'll be squared, yeah, a and b times b times b. Okay, now we have to do the same with the 48 ones, 48 ab cube. So how we can factorize 48 is 2, that will be 24, 2, that will be 12, 2 and 6 and 2 and 3 and 3. So this is the prime factorized form of 48. Now I'll write that down. 48 ab cube, that will give me 2 times 2 times 2 times 2 times 3 times a, and into b into b into b. Now if you remember, to find the HCF of any two numbers, we only have to look at the ones which are common in them. So now the common things we can see here in 42a square b square and 48ab cube is there's a 2 here, right? And there's a 2 here. So that now for the HCF, we're gonna write the 2 down because there's a 2 common. And then if you notice, there's another 3 common as well. So into 3, and the a is also common. There's one a, so I'll write a, and 2 b's are common. So I'm gonna write b into b. Then I'm gonna get 3 2's are 6, a and b into b is b squared. So the HCF of 42 a square b square and 48 ab cube is 6 ab square. The second question is find the HCF of this whole polynomial and this polynomial. Now how to do that is we have to write the constants which we have in its prime factorized form as we did in the previous question. So here 96 is going to be 2 power 5 into 3, and it's going to be x minus 1 into x plus 1 squared into x plus 3 cubed. Okay, now this is the first term, okay, and the second term is going to be 64. 64 is 2 power 6, yeah, 64 is 2 power 6 into, now here I want to show you something. X square minus 1 is same as x square minus 1 square, right? Now this can be written as x plus 1 into x minus 1. So that's what I'm going to do here. I'm going to write it in that form. So I'm going to write x square plus minus 1 as x plus 1 into x minus 1. Okay. Now the next one is x plus 3 into x plus 2 square. Okay. Now to find the HCF, as I said before, we only have to look for what are the common ones. So now in this, the common ones are 2 power 5. There's 2 power 5 in both, and that will be 2 power 5. If you're wondering how this is a 2 power 6, well, it's basically 2 power 5 into 2, right? So that will be 2 power 5 is common. We're going to take 2 power 5 out, and x plus 1 is common. So I'm going to write into x plus 1. Here is a square, but x plus 1 into x plus 1 is x plus 1 whole square. So I'm going to write 1s because only 1 is common. And now I have x minus 1 common here. So I'm gonna write into x minus 1, and then I have a x plus 3 common as well. So now I'm gonna write x plus 3. Now also same applies here, x plus 3 squared into x plus 3 is x plus 3 cubed. Okay, now we have to solve this here because we usually it's not preferred to leave it this way. So now this 2 power 5 is 32, and x plus 1 into x, I'll write it with a different color. Okay, 2 power 5 is 32, and x plus 1 into x minus 1 is x as now I just showed you, right, that x square minus 1 is same as x plus 1 into x minus 1. So that's what I did here. Now I'm gonna take this, that's x squared minus 1, and I'm gonna write into x plus 3. So this is going to be our this is going to be the HCF. This is the HCF of these two polynomials.